Hey there! In this video, we're going to see how we can implement saving and loading into our game by creating customizable controls. The player will be able to set their preferences in different profiles, and then these options will be kept even when the game is closed. Most modern games have some sort of saving feature, even if it's just a simple high score, and then allowing your player to customize their controls is going to really enhance the user experience, and it's going to lend them a bit more freedom. And real quick, this channel is really close to getting 1,000 subscribers, which would allow me to monetize it, so please consider subscribing. It's free, just takes one click, and it would really help me out since YouTube already plays ads on my videos. By being monetized, I'd be able to see a little bit of that revenue and continue growing the channel. As always, all code and assets can be found on my GitHub, which I will link down in the description below. The only external asset this tutorial is going to require is this retro gaming font file that you can get from dafont.com. I'm going to go ahead and leave a link in the description to download it directly, but also leave a link to dafont.com where you can download the zip file and extract it yourself. Once you've gotten your hands on that file, go ahead and open up your favorite IDE, and you can head in there and paste it in. From there, we're going to create a new file called main.py, and main.py is just going to be a really simple game loop that we can use to test our controls and saving feature. Now, even though I'm using this simple little game loop, I'm going to go ahead and try to modularize everything that I'm doing. That way, if you want to follow along with, say, my states or menu tutorial, or you have your own game framework you want to try to apply this to, you should be able to do that with very few hiccups. Like all Pygames, we're just going to go ahead and start by importing Pygame. From there, we can do pygame.init to get everything ready, set our display width and height, and then make a surface that will act as our canvas so we can draw things onto our game. From there, we can create a window, which will be twice the width and height of our canvas, so we can upscale it, and a boolean variable to keep track if the game is running or not. So next, let's make a dictionary, which we'll call actions. These are just going to correspond to the controls in our game. So here we're going to have a left, right, up, down, start, and some sort of action button. But depending on your game, you can feel free to add or subtract from this dictionary as you see fit. So now let's go ahead and make our actual game loop. We're going to start with the while loop. So while the game is running, we're going to go ahead and just check for an event. In this case, the only event we're going to check for at the moment is if the player wants to exit the game. That way we don't have some sort of infinite loop. We can just set this running variable to false and the game will end. So normally this would be where we update our game, but right now there's not much to update, so we're going to go ahead and leave that blank for now. We're going to go ahead and do a canvas.fill just to give our screen a nice shade of blue, and then we're going to go ahead and blit our canvas onto the window and display our window onto the screen. That's about everything we're going to need for now, so let's go ahead and run this just to make sure it works. So when I go ahead and run this file, we get this nice blue window, and then when I go ahead and close it, it does just that. Now we can get into the real meat and potatoes, which is going to be the saving and controls feature. Let's go ahead and make a new file, which I'll call util.py, and util.py is going to contain most of the code that handles saving. Let's go ahead and start by importing some modules that we're going to need. So in this case, it's going to be the OS module, the JSON module, and the Pygame module. Now some of you may have already guessed, but we're going to handle saving by storing our data inside JSON files. And we like JSON files because they're really easy to use and they correspond very well to Python dictionaries. Let's create our first function, which I'm going to call createSave. And what this is going to do is it's going to run when the player has no previous save file. This is essentially going to be the default controls that we give them at the start of the time that they ever boot up the game or if their file gets deleted. This setup can look a little daunting, so let's go ahead and go through it real quick. The way it's going to work is that our save file is going to be a dictionary that matches some sort of string to some sort of other object. So for example, the control string is going to match to a profile string. So each of these strings, 0 or 1, keeps track of a certain control's profile that the player can switch between. From there, the 0 or 1 string is going to match to the actual controls. So for example, if you click the 0 profile, then we can have the left, right, up and down controls for that profile, which is going to be A, D, W, and S. So in short, we have a string that matches to a string that matches to a dictionary. And then within this dictionary, we can use a string and it'll get us our controls. We're also going to have this variable here, current profile, that's just going to keep track of which profile the player currently has set as their preferred. Now let's go ahead and make some functions pertaining to those JSON files. The first one is going to be called loadExistingSave. What we're going to do is pass in the name of some sort of JSON file. From there, we're going to try to open it. Using the os.path.join along with the name of the save file, let's go ahead and try to read it as file. Once we read it as file, if we're able to open it, we're going to go ahead and load the contents into a dictionary and store that dictionary into a variable called controls, which we can then return. So if the player boots up the game and already has an existing save file, this is the function that we expect to run. Next, let's go ahead and make a function, which we're going to call writeSave, and this is going to run anytime we're making a new save file, or we're overwriting an existing save file. So aka, anytime the player wants to change their controls, this is what's going to ensure that their control actually gets saved correctly. The way this is going to work is we're going to pass in some sort of data, which should be in the form of a dictionary. From here, we're going to look for a file called save.json, and it should be in our current working directory. If it's not, then we're going to go ahead and write a new one. And if it is, then we can go ahead and overwrite the old one. From here, we can go ahead and use json.dump. We're going to dump our data, which is basically a dictionary, and save it onto the file. These two functions are most of the bread and butter of what we're going to need to make our saving system work. Let's just add one more function that's really going to piece them together. I'm just going to call this function load_save. This is the function we're actually going to call when we first boot up our game and try to load our save. The first thing we're going to do is use this try block to try and load an existing save. So we're going to use that function and try to find a save.json file. Now if it doesn't work or it's corrupted, we're going to go down here to this except line. And what this is going to do is just create a new one. So we can create our save, and then we can write it so that it exists. From there, we can just return the save, whether it be the new one or the existing one. Now that's pretty much everything except for one last function we're going to include, but we're not really going to need to use it till later. We're just going to include a function that's going to take in our actions dictionary and just reset all the keys to false and then return it. Like I said, we're not going to use it till later when we actually need to traverse our menu, but let's just keep it here for now. That way we can just be done with the util.py file. Now let's go ahead and go back to our main game loop. That way we can try some of the functions that we just made. So from util, we're going to want to import load_save, and we're also going to want to import reset keys. Like I said, we're not going to be using reset keys till later, but let's go ahead and try load_save. Let's go ahead and attempt to load our current save by calling the load_save function, and we're going to just store it in a variable called save. Now let's go ahead and test it. Since we don't already have a save file, what we'd expect is that if we run the code, we should generate a new one. And that's exactly what happens here. We get this save.json file, and when we look through it, we see all of the default controls. One interesting thing to note is that if we go back to util.py, in our dictionary, we have these Pygame and then constant values. But if we look in save.json, we can see that those constant values really just map to integers. So each integer just acts as a code for a certain thing on your keyboard. That should be everything we're going to need for our util.py file. So now let's go ahead and make another one, which I'm going to call controls.py. And controls.py is going to handle everything control related in our game. Let's start by making some imports. So we're going to want to import Pygame, the sys module, and then we're also going to want to import that writeSave function that we made in our util.py file. I'm going to make a class which we'll call controls_handler. And this controls handler is going to have all the tools that we're going to need to render our controls onto the screen, as well as change them when the player wants to. Let's go ahead and start by creating an init function. This init function is going to take in some save data, which is going to be the dictionary that we initially load in from our game. From there, we can create a pointer to it. That way we have access to it anytime we want in the controls handler, and then we can gather some more information from it for ease of use, such as the current block and the current controls that the player is set to use. And remember, because our JSON file is essentially just a dictionary, we just need to put in the right key to access the desired information. One last thing I'm going to put here is this self.setup function. This function doesn't exist yet, but we're going to make it very shortly. So let's go ahead and make that setup function. And it's just going to start by initializing a few variables. First, we're going to have a self.selected variable, which is just going to let us know if the player has selected a control to change or not. And then we're also going to initialize our font by putting in pygame.font.font, and then the name of our font file here, which in my case is retrofont.ttf, and then the size, which I'll put to 20. Let's go ahead and make a little framework for our cursor. So we're going to start by declaring an empty dictionary, and we're going to set the current index equal to 0. From there, we're going to go through and populate our dictionary. So we're going to have integer keys from 0 to however many controls we have -1 that are going to map to our controls. So for example, our 0 integer is going to map to the left control, 1 is going to map to the right control, etc., etc. At the very end, we're going to create one more entry in our dictionary, and this is going to be the option for the player to set whatever profile they're currently on to be the controls they want to use. That's everything in our setup function. Now let's work on getting all the controls in our save file onto the screen so we can see them. So let's go ahead and make another function, which is going to be called draw text, and this is a very similar function to every other draw text function I've used in my other tutorials. By providing a surface, some text, a size, color for our text, and then an X and Y coordinate, we'll be able to use this function to draw text and render it onto the screen. Feel free to pause the video if you need to type it all out. Let's go ahead and add two blank functions to our controls handler. We're going to have the update function and the render function, and we'll fill these out as we continue the tutorial. Let's go ahead and work on rendering our controls onto the screen so that we can see them and know that our save file is being loaded in correctly. Using the draw text function, we're going to print the number of the control profile at which the player is currently looking at. We have this value in the current block variable, and then we'll add 1. Because this technically starts from 0, we're just going to make it start from 1. That way it makes a little bit more sense to human players, and then we're going to convert it to a string. Now let's go ahead and make a helper function that will print the controls. The first thing I want to do here is draw our cursor, which will be represented by a rectangle. We want to draw the cursor first, so that way it'll go behind the text and give that nice highlighting effect. The color of the cursor is going to depend if the player has selected a control or not. So if they selected a control that they want to change, we'll make the cursor red, but if they're just scrolling around, then we'll just make the cursor white. After we've gotten our color, then we'll go ahead and draw a rectangle at the correct position. So we're going to put x equal to 80, and then we're going to do 270 divided by 4 minus 10 for a little offset, and then we're also going to add the current index times 30. So whatever index the player is currently on, we'll add that value times 30, and it'll go down that many times. So for example, if we don't press anything, then this current index value will stay 0, and we won't add anything, and the cursor will stay at the top. But if we press down once, this current index value will change to 1, we'll add 30 to the Y, and we'll see our cursor go down. So now let's go ahead and print our controls to the screen, and we can do that this way. So we're going to start by declaring a temp variable I and equaling it to 0, and then for every control in our controls dictionary, we're going to iterate through and draw the name of the control, so whether it's left, right, up, down, etc. And then we're going to put a dash, and we're going to see what keyboard key it actually maps to. So whether it be A, S, D, W, or your arrow keys, etc., etc., we can use pygame.key.name to put in the integer code and actually see what key that maps to. Every time we do this, we're going to increment I by 30. That way, when we draw the next control, it also gets incremented by 30, and we add it to the Y coordinate here. And then lastly, we're going to print one more thing to the screen. This is just going to be that set profile option, where they can use whatever current profile they're looking at and set it to be their main one. This function's done, so now let's go ahead and add it back into our render function. We're going to call self.displayControls and pass in two parameters. The first one's going to be the surface that comes from here, and then next we're going to pass in the controls. So what we're going to do is we're going to use our save file, access the controls, and then whatever profile we happen to be looking at, we're going to go ahead and call that one there, which can be used in our current block variable. One last thing we're going to add to this render function. So if the current block, which is the profile we're currently looking at, is equal to whatever current profile the player has set to be their controls, then we're just going to draw a little asterisk in the corner, letting the player know that these are the controls they're currently working with. Let's hop over to main.py to make sure that our render function is working correctly. So first thing we're going to want to do is import our controls handler class, and now we can go ahead and make an instance of it. Right after we load our save, I'm going to go ahead and make the instance of control handler, and then I'm going to make sure that I pass in that save variable into the constructor. Now we can scroll to the bottom of our game loop, and after we reset the screen with the canvas.fill, let's go ahead and render our controls handler and just make sure to pass in that canvas. When we run our main.py file, you'll see that it prints out our control profile 1, which is also currently our default, and then we also have all of our controls, so left is A, right is D, etc., etc. Now at the moment, there's no way to navigate or change any of the controls, so let's go ahead and go back to controls.py and we can fix that. Back inside controls.py, let's go ahead and make a new function, which I'm going to call navigate menu, and it's going to go ahead and take that actions dictionary as a parameter. From there, we can look through the different actions to decide how the cursor needs to behave. If the player presses down, we're going to go ahead and add 1 to the current index, and if the player presses up, we're going to go ahead and subtract 1 to the current index, and then we can use some modular arithmetic and mod by the length of however many options we have, in this case, the number of controls, plus 1 for that extra set profile option at the end. This will ensure that our current index never goes out of bounds, and then it'll also give us that nice looping behavior. So for example, if they're at the very bottom of the list and press down, it'll go all the way back to the top. We can apply the same logic to switching between profiles. So if the player presses left or right, we're going to apply the same formula to the current block, and from there, we'll be able to switch between our first and second profile. Once you've taken the time to write all that out, go back to the update function at the very top, and then go ahead and call self.navigate menu and make sure to pass in the actions dictionary. Let's run back over to main.py and make a few adjustments so we can test navigating our menu. Currently, our actions dictionary isn't being updated, so let's go ahead and change that. How we're going to do that is we're just going to go and add to these pygame.keydown statements. So along with the escape to end our game, we're also going to want to check for each of our keys, such as the left, right, up, down, etc. So what we're going to do is we're going to check to see if the event.key is equal to the control handler, .controls, and then whatever key we want to check, whether it be left, right, etc. And then we can set the actions equal to true if the key is being pressed down, or if the key is being pressed up, then we can set it to false. I'm going to go ahead and leave these on the screen for a little bit, and feel free to take your time and copy them. Once you're done, go ahead and call the update method from our control handler and make sure to pass in the actions dictionary. And then at the very end of our loop, we're going to go ahead and reset the keys, and this is just to ensure that the player can scroll through the menu pretty seamlessly. So now, when we go ahead and run our file again, we're now actually able to traverse through all of our controls, whether we go up or down. And then if I press left or right, it'll go ahead and switch me between my two profiles. And as we can see, the first profile is still set as our main one. So what's left to do is allow the player to customize the controls and also determine which of the two profiles they want to use as their main method. Let's go back to our navigate menu function so we can add the case where the player actually selects one of the options. And we're going to allow the player to do that by either pressing the action 1 or start button. If the player selected the set current profile option, then what we're going to do first is we're going to set our controls to be whatever the controls are that the player is currently looking at, and we can do that by setting it to the current block. After that, what we're going to do is we're going to overwrite the current profile option in our save file, and we're going to set it to the current block as well. And then we can go ahead and use that write save function, and because we've been editing the save file dictionary, we'll go ahead and pass in the save file as well, and it'll overwrite save.json. Now if the player didn't select the set current profile option, that means they selected one of the controls that they want to change. So for now, we'll do self.selected equal to true, and we'll use this else statement to ensure that we capture all the controls. So now let's make one last function, set new control, which will allow the player to do just that. First we need to check which control the player actually wants to change, and we can do that using the cursor dictionary and the cursor index. Because we don't want to cause any infinite loops, we're going to make sure that if the player presses the little X at the top of the window, the game will still close. And then we can also call pygame.quit and system.exit for good measure. We're then going to check for pygame.keydown statements, and we're going to apply the same logic to what happens if the player presses escape, so we'll just use escape as a hard key to end the game. Now if the player presses a key that is an escape, then we're going to want to make sure that we check that it's not already a duplicate control. We can check that with this line right here, so event.key not in our current profile, which we can access using self.savefile, controls, the current block, and then we can get the controls from the .values method. If the event.key passes all of this, then that means whatever key the player picked is valid, and we can now change their controls. So what we're going to do is apply the same logic we did before with the profile. We're going to change the actual value of that key to our event.key, and then we're going to go ahead and write the save file. Once we've done that, let's set our self.selected and done variables to their opposites. So now that we've finished that function, let's go ahead and call it in our update, and this is how we can do it. What we're going to do is check to see if the self.selected variable is true. If that's the case, we'll call set new control. Otherwise, we're going to call navigate menu. With that, our control handler should be complete, so let's go ahead and test it. In our main.py file, let's go ahead and run it. Let's switch over to control profile 2. I'm going to try to change all these to the arrow keys. So if we press left, then we go left. If we press right, we go right. Up is up, and down is S. And just to make sure this is working, let's try to change the start button to space, and it shouldn't do anything. So if I do that, Even though I'm pressing space, nothing's happening, and that's because it's already taken up by the Action 1 button. So I'm going to go ahead and press P, and we'll use P as our start. Now let's go ahead and set it as our current profile. And then when we close this program and run it again, you can see that all of our changes are still taking place. If I then use the arrow keys to switch back to control profile 1 and set it as my current profile, I can now use A, D, W, and S to move around again. And if I close it, it'll open right back up at profile 1 because that's my last selected current profile. Looks like our custom controls are saving and loading properly, so I'm going to end the video here. Please consider leaving a like or subscribing, especially if you found the video useful. It helps the channel grow, and I'm really looking forward to making more videos. Thanks for sticking to the end of this one. I appreciate you as always. Stay safe and take care.